and welcome to Cherry Pie Math. This video is going to go over proportional relationships, what is and what isn't. So to start, we're going to just take a look at this airplane, and I want you to pause the video and see which airplanes are proportional to this yellow one up here at the top. Okay, so this one and this one and this one and this one are all proportional. The other two are not proportional because, as you can kind of see, they've been squashed a little bit, and so they don't really match the original shape of the original picture. This leads us to the idea of proportionality. We want to talk about what does it mean to be proportional, and you've probably heard this word just in daily life, but in math we have a special definition, and it's if it has the same scale factor from the original to the new. And there's a reason I write original to new, because it doesn't just apply to the image, like a pre-image to an image like we had with the airplane. We also have this idea of proportionality with variables. So I can actually go from a variable to another variable and check for proportionality that way. So we're going to kind of look at this in the context of graphs, tables, and equations. We'll start with graphs. As we can see, we have 3 lines here. Our job is to figure out which ones represent proportions. They are proportional if the line is straight and passes through the point 0, 0, which is also known as the origin. So if we look back at our graphs, like I said, they're all straight lines, but only 2 of them are proportions, and we can tell because this green one here, it goes through 3, that y-intercept of 3, and the other 2 have a y-intercept of 0, 0. It passes through that origin, so only blue and red are actually proportions. They're comparing x and y, and we can tell because they're flat through 0, 0 through the origin. And actually, I'm going to cross that out and write straight because flat to me makes it sound like there's no rise at all, but it does have a slope. It's slanted, right? We do want to find the unit rate. The unit rate is how far it goes in one space. So the blue line is pretty easy. We can tell it goes up 2 in that one space. So the unit rate is 2. The red is a little bit harder because at that 1 mark, it's not actually at a nice point, and we can kind of see like it looks around like a half-ish, like just close to a half, a little bit less than a half. So another way to tell a unit rate is to find an actual nice point like this red one I just drew, and to see how far we go up and how far we go to the right. So I went up 1, I have a +1 there, and then I went 3 spaces to the right to get there, and so my unit rate is actually 1/3. And that makes sense because if I go back to that point on the purple line that I drew, you can see that it's about 1/3. So the unit rate is 1/3. We'll talk more about that later. The green one is not proportional. It doesn't pass through the origin, doesn't go through the origin. But it does technically kind of have a unit rate because we can tell how far it goes in one space. So in one space, I go up 1 and I go across 1, which means that my unit rate for green is actually just 1. Every time I go 1 on the x-axis, I also go 1 on the y-axis there. Next up, we're going to be talking about tables. And you've probably seen tables before. And in a table, we can tell that they're proportional if every x is multiplied by the same factor, like a scale factor, to get to y. So if we look at this table here, we can consider the pancakes to be x, and we consider the flour and the sugar to be y1 and y2. They're 2 different y's, but they both relate to x, the number of pancakes that we're trying to make. If I'm trying to tell the amount of flour, if it's proportional, I need to check if each number of pancakes, because that's my x, is multiplied by the same factor to get flour. The easiest way to do that is actually not to like guess and check, it's to divide. So if you divide like the flour by the pancakes, it's because it's the same thing, like multiplication and division are related to each other. So if I divide the cups of flour by the number of pancakes, for example, like 1.5, if I divide that by 8, let me write that down. I will get a number. In this case, it's 0.1875. And spoiler alert, it's actually going to be the same for all of them. It will all be 0.1875 if I divide the cups of flour by the number of pancakes, which would mean that if I was trying to get from the number of pancakes to the cups of flour, I would multiply by 0.1875, and I would end up with the same numbers there. So we can tell it's proportional because each of them are multiplied by the same amount. So, and then if I'm trying to see if the amount of sugar is proportional to the amount of pancakes, I need to kind of do the same thing. So if I do like 1/16 divided by 8, I get 0.0078125. And it's going to be the same for most of them except the last one. That last one, 1/4 divided by 24, ends up being something totally different, 0.0104167. And so we can tell that this is not proportional because that last one was not the same as the others. It doesn't have the same factor. So no, they don't all have the same scale factor. I didn't multiply them all by the same thing. And that's kind of the way to do it with tables. It's a little tedious, but you can check for all of them. So our last format that we're going to be talking about for proportionality is equations. And with equations, we can tell if they are proportional if the equation looks like y equals mx. So y is a variable and x is a variable. M is special. We're going to be talking about M a lot, and especially in the next couple of videos I'm going to make, I'm going to talk about it more. And right now we're just going to call it the scale factor. It's when I'm multiplying by x. So if I look, I can see like the first one is obviously in that format, y equals 5x. M has to be a number. The next one, a equals 1/9, b is also okay. Fractions are fine. They are just a number. As long as m is a number, it's fine. The next one is not, because we're subtracting 1. We cannot be adding or subtracting anything if it's a proportion. The last two are harder to tell because they're a little bit different, but there's only 2 that are not proportional. So we'll get to those in a second. Spoiler alert, 8g equals 3h is proportional, and we'll talk about that in a second. Okay, so I can tell that t equals 3r minus 1 is not proportional, and also p minus q equals 8 is not proportional either, for the same reason I talked about before. They have addition or subtraction. If you have addition or subtraction, it is no longer a proportion. So for those last two, we had to change them a little bit because it's hard to tell if it's proportional just by looking at it, because they don't necessarily match the y equals mx format that I had earlier. So let's start with the 8g equals 3h. If I divide both sides by 8, that actually gets rid of the 8 in front of the g, and I have g equals 3/8 h, because 3 divided by 8 is just 3/8. And the other one, I can add q to both sides, and that'll move the q over, and so now I have p equals 8 plus q. The reason I did this is because I need to do something that's called isolate the variable. Because if I don't isolate the variable, I can't make sure it looks like y equals mx, because if you look back, y is by itself. So when you're checking for proportionality in equations, make sure you isolate the variable, just like there and just like in all the other ones that we checked, so that we can see if it's proportional. So that kind of concludes part 1. I was originally going to have a really long video, but it was like 20 minutes long and no one wants to really watch a 20-minute video. So the first part talked about how to recognize proportionality in graphs, tables, and equations. My next video is going to talk about the unit rates from those, because all of them have something called a unit rate, and that unit rate is actually super important, especially if we're trying to build towards graphing lines. So go ahead and check out my second video there, but hopefully this helps. And if you have any questions about how to find proportionality in those 3 forms, let me know in the comments, and good luck.